Let's consider the formula for the period of a simple pendulum of length L. This formula is T, the period, is equal to 2 pi times the square root of L over G. And L is the length of the pendulum. Now, on Earth, we tend to regard G as being fixed. It varies a little with altitude, but we tend to think of it as being fixed. But just supposing we had a pendulum of a fixed length L and we took it somewhere else, let's say the Moon or Mars, somewhere out of the solar system. Gravity there would not be the same, and we might want to measure gravity. So one of the ways would be to take our pendulum, set it swinging, and measure the time. Once we'd measured the time, we could then use that to calculate G. But before we could do it, we would need to know what G was in terms of the rest of the symbols in this formula. So we'd need to rearrange this formula so that it said G equals. Now, it's what goes instead of this question mark that we're going to have a look at in this video. We're going to be looking at how we transform formulae, how we move from an expression like this to another expression involving exactly the same variables, but one that helps us answer the questions that we're after in terms of a different variable. To do this transformation of formulae, we'll need all the techniques that we had in terms of solving equations. So the video solving linear equations in one variable might be very useful to have a look at. But let's just recap by having a look at a simple linear equation. So the one I'm going to take, 3x plus 5 equals 6 minus 3 times 5 minus 2x. Now, we've got this equation, we want to solve it for x. So our aim is to end up with x equals. So one of the first things we would do is multiply out the bracket. So we have minus 3 times by 5 is minus 15. Minus 3 times by minus 2x is plus 6x. Next, we can simplify this bit here. 3x plus 5 equals 6x, and now 6 take away 15 is minus 9. Now, one of the things we would want to do is to try and get all the x's together. So we have a 3x here and a 6x there. So we'll take 3x away from each side. So that's 3x take away 3x plus 5 equals 6x take away 3x minus 9. 3x take away 3x, the x's go, we've none left, and then we've got this 5 is equal to 6x take away 3x, that's 3x again, take away 9. Now we need to get the constant terms, the numbers together. So to do that we would add 9 to each side. So with 5 plus 9 is equal to 3x minus 9 plus 9. So again, we're doing the same thing to both sides. Here we took 3x away from each side. Here we're adding 9 to each side. So 5 and 9 is 14 equals 3x, and with minus 9 plus 9, that's 0. Now we need to divide both sides by 3. So we have 3x over 3 and 14 over 3, dividing both sides by 3, and so those 3 cancel, and we're left with x equals 14 over 3. Now, I've written this out very fully. I've written out every step that I've said, but we wouldn't normally expect to see all of that written down. starting from here, the next line we'd expect to see is this one, because we'd say take 3x away from both sides, and we'd expect to see that as the result. Then we'd say add 9 to both sides, and so what we would expect to see having done that would be that. And then we'd say divide both sides by 3, and so we'd see that. So what we would see written down in our exercise book or on a piece of paper that carried the solution to this equation would be something like this. Okay, we've been through the steps now of solving an equation, and these techniques, particularly this idea of a balance, of keeping the same on both sides by doing the same thing to both sides, is what we're going to do when we look at the transformation of formulae. So let's begin with our first formula, v equals u plus at. And the variable that we're going to try and find is t. T is the variable we're going to find. What is t expressed in terms of the rest of the letters or symbols that there are in this formula? Well, in order to model this, what I'm going to do is I'm going to write down an equation which looks like this, but it's just got numbers in, with a t there as the unknown. So what we might have is something like this. 7 for v, 5 for u, let's say a 2 for a, and then t. Now, what would we do to solve this equation? Well, the first thing we'd try and do is get the t's on their own. And so to do that, we'd take 5 away from each side. So this would be 2 over here equals 2t. So having done that there, let's do it here. v minus u, taking u away from each side. Now we would divide both sides by 2 over here in order to end up with just t on its own. So let's do the same here. A is what multiplies by t, so we need to divide everything on this side. v minus u over a equals t. And that's it. Notice everything here is over a, not just one part of it, but both, the whole expression, v minus u over a. Let's take another one. V squared equals u squared plus 2as. And this time, let's say the symbol that I'm going to try and find, or the variable that I'm going to try and find in terms of all the others, is u. So if that's the case, again, I'm going to write down an equation over here which looks like this one. So let's have 25 equals u squared plus 9, where the 9 is in place of this lump here of algebra. So what would we do here? Our first step would be to take 9 away from both sides. So let's do that. 25 minus 9 equals u squared. And that gets us the u squared on its own. So let's do that over here. Let's take this lump away from both sides. V squared minus 2as is equal to u squared. Now, what I would want to do now is to take the square root of both sides, because I want just u. And here I've got u squared. So I need the square root of 25 minus 9. And I want the square root of all of that, not square root of 25 minus the square root of 9. I want the square root of 25 minus 9. So again, I've got to do the same over here. I want the square root of all of it. let's just check why I need the square root of all of this. 25 minus 9 is 16. So that's 16 equals u squared. Take the square root of both sides. 4 is equal to u. And we're happy that's the answer. But what if I do the square root of 25 minus the square root of 9? Well, that's 5 minus 3 is 2, which is not the answer. Very definitely not the answer. So we need to take the square root of everything, not just each little piece. And so this over here has to be the square root of all of that. I've been working so far with the formulae that are for uniform acceleration. So let's continue with that and take another one of them, s equals ut plus a half a t squared. And this time it's a that I'm going to be looking for. Can I rearrange this formula? Can I transform it so it says a equals? Again, let me model it with an equation. Let's say that s is 21, that u times by t is 15, plus a half of a times by 9. And it's this a that I'm after. First of all, let's isolate the term with the unknown in it. So that's the a term. So let's take 15 away from both sides. So 21 minus 15 is equal to a half of a times by 9. So again, let's do that here. Let's take this lump away. S minus ut equals a half a t squared. So again, my first steps are to try and isolate the variable, the term that I'm looking for. Now this one looks a bit complicated. We've got a half there. It would be nice to get rid of the half, so let's multiply both sides by 2. And if we do it at this side, that's just a times by 9. If we do it at this side, 2 times 21 minus 15. And it multiplies all of it. So let's do the same here. Multiply both sides by 2. 2 times s minus ut equals a t squared. Going back to the equation, we've got equals a times by 9. I just want a on its own, and so I must divide both sides by 9. Here, the thing that's doing the multiplying is t squared. So let's divide both sides by t squared. And in the same way as I divided everything by 9, I've got to divide everything here by t squared. And that gives me a. Notice I haven't made any effort to cancel because t is not a common factor. It is not a common factor. Now, we've been working with the equations that are to do with uniform acceleration. But there are some other kinds of equations that we need to gain practice at. And in order to develop these skills, I'm going to start with some made-up equations that don't have physical applications in the real world. But we will come back, once we've developed those skills, to looking at some real equations that do contain physical applications that we will be able to transform. But we need to develop some skills to begin with. So first of all, let's take this expression, let's call it, rather than a formula. So there we have y times 2x plus 1 equals x plus 1. And the thing that we're going to be after is x. Can we rearrange it so it says x equals? Well, again, let me try and model this with an equation. So all I need to do to model this as an equation is replace the y by 3. And if I was to solve this as an equation, my first step would be to multiply out the brackets. So let's do that. 6x plus 3 is equal to x plus 1. So let's do that over here. Multiply out this bracket. So that's 2xy plus y is equal to x plus 1. Our next step with the equation will be to get all the x's together. So I would take x away from both sides. So that would be 6x, take away x, plus 3, and taking the x away from this side just leaves me with 1. So let's do that here. Let's take this x away from both sides. So I have 2xy minus x plus y is equal to 1. Now, I would naturally want to combine these two in some way. 6x minus x is just 5x. I can't really do that at this side, but what I can do is gather together the terms in x by taking out x as a common factor. So we take out x from this as a common factor, and the other factor is 2y minus, and taking x out of there is 1, plus y equals 1. What now? Well, now I've got my x's together over here. Let's write this as 5x plus 3 equals 1. My next step will be to leave the x term on its own by taking 3 away from each side. So let's do that here. Leave the x term on its own by taking the other term, that's y, away from both sides. Now I'm just going to simplify this. 5x equals minus 2. And in order to solve this, to get a value of x, I need to divide both sides by this number 5. So that's x equals minus 2 over 5. So if I come back to this term in the bracket, 2y minus 1, is the term that's multiplying the x. And so I need to divide both sides by it. So x is equal to 1 minus y over 2y plus, sorry, made a mistake there, 2y minus 1. Let's just look again at what we've done here. We've mimicked the solving of an equation. First, we multiplied out the brackets. Then we got the terms together in x, the variable that we were after. Having got those terms together, we then isolated them so that they were on their own. So we need to bear that in mind and follow it through. Let's take another expression, y over y plus x plus 5 is equal to x. And this time we're going to be finding y. We're going to be getting y equals, and we want some lump of numbers and x's over this side. So let's model this with an equation. Y over y plus 3 plus 5 is equal to 3. Let's look at this side. Here we've got an algebraic fraction. Y over y plus 3. Y plus 3 is the denominator. It's in the bottom of the fraction. So in order to get rid of that, we need to multiply everything in this equation by this denominator. So I'm going to write that out in full. Y over y plus 3, and I'll put that in a bracket, times y plus 3 plus 5 times y plus 3 is equal to 3 times y plus 3. Let me just emphasise, we have to do the same thing to both sides. So here I've had to multiply everything on both sides of the equation by this term y plus 3. Here, those will cancel out, just leaving me with y. So let's do that at this side. Let's multiply everything by this term y plus x. So we know this first one, when we've multiplied it by y plus x, is just going to give us y plus 5 times by y plus x is equal to x times by y plus x. Coming back to the equation here, faced with a lot of brackets, we know the first thing we would do is multiply out the brackets. So let's do that. Y plus 5 times by y is 5y, and 5 times by 3 is 15, is equal to 3 times by y is 3y, and 3 times by 3 is 9. Do the same here. Y plus 5y, 5 times by x plus 5x is equal to x times by y is xy, and x times by x is x squared. On this side now, we would look to get all of our y's together. So with y plus 5y is 6y, take away 3y. So we've 6y already, and we're going to take away 3y. Plus 15 is equal to 9. So let's gather all the y's together. Y plus 5y is 6y. And I need to bring this term over, so I'll take xy away from both sides, minus xy. And then let's just write down the other terms. Now here I would simplify this. I'd have 6y take away 3y, and that would just leave me with 3y plus 15 equals 9. Now, I can't do that here, but the thing that I can do is bring them much closer together by taking out y, the thing that I'm after, as a common factor. So let's take y out of these two terms. Y, brackets, y times by 6y means I must have a 6 in there, minus xy means I must have a minus x there, plus 5x equals x squared. And now over here, I'd isolate this term in y by taking 15 away from both sides. 3y is equal to, now this is 9 minus 15. So I've got to do the same here. Take 5x away from each side, isolating this term in y. Y times 6 minus x is equal to x squared minus 5x. At this side, now I've got 3y, I just need y. So I would divide everything on this side by 3. So I've got to do the same with this. I've got to divide everything on this side by this term 6 minus x. So we have x squared minus 5x divided by 6 minus x. And put it all in a bracket to keep it together. Notice I'm attempting no cancelling because there is no common factor in this numerator and this denominator. They do not share a common factor. So that's my answer, and I finished. I've got y equals a lump of algebra involving x's and numbers. We started with a real formula. We started with the formula for a simple pendulum of length L. T equals 2 pi square root of L over G. And the problem that we posed was, well, what was G in terms of T? So G is what we're after. G equals. Let's have a look at a simple equation. Let's say it's 10 equals 2 pi. And I'll keep the 2 pi because pi is just a number, so 2 pi is just a number. Square root of 3 over G. Now, as an equation, this one's a bit tricky because the G is trapped inside this square root sign. We need to bring it out. And the way to get a square root sign to disappear, so to speak, is to square both sides. Reverse the operation, if you like. So we'll square both sides of this equation. So 10 multiplied by itself, I'm going to write it as 10 squared, equals 2 pi multiplied by itself, because we're squaring the whole of both sides, times by, and I square this, 3 over G. Now we need to do the same here. Square the whole of both sides. So that will be T squared, 2 pi all squared, L over G. It's coming back to the equation. G's in the denominator. I don't want it there. I want it to say G equals. I want G upstairs, so to speak. So I have to get rid of it out of the denominator, and so to do that I must multiply both sides by G. So I've got 10 squared times G is equal to 2 pi squared times 3. So let's do that here. Multiply both sides by G. So I have T squared times by G is equal to 2 pi all squared times by L. Now it's G I want on its own. I want to say G equals, so I must divide by this thing 10 squared. So G is equal to 2 pi all squared times 3 all over 10 squared. And I can work that out. Well, let's do the same with this. G equals 2 pi all squared times by L, and I'm getting rid of this T squared by dividing everything by T squared. And we can leave it like that. We can make it look a little bit nicer, if we want to, by spotting that we've got a square here and a square there, and it might be nice to combine those two squaring processes by writing 2 pi over T all squared times by L. Basically, this is the answer that we finished with. Let's take another couple of examples of real formulae that we might want to be able to manipulate. So let's have a look at the lens formula. 1 over F is equal to 1 over U plus 1 over V. Let's say it's U that we're after. We want U equals. Well, let me write down an equation that's similar. 1 over 3 equals 1 over U plus 1 over 5. Now I want to isolate this term first in 1 over U. To do that, I'm going to take this away from both sides. 1/3 take away 1/5 is equal to 1 over U. So let's do that. Isolate this term in U. And so to do that, we take away 1 over V from both sides. So with 1 over F, take away 1 over V is equal to 1 over U. Now, faced with problems like this, it's very, very tempting to simply turn everything upside down. Well, let's just have a think about that. This says 1/3 minus 1/5. Now, 1/3 is bigger than 1/5. So 1/3 minus 1/5 is a positive number. So u at the very least has got to be positive. Watch what happens if I just turn everything upside down. 3 minus 5 equals u, which tells me that minus 2 is equal to u. But we just agreed that u had to be positive and not negative. You can't do that. These are fractions, and so because they're fractions, we have to combine them as fractions, which means we have to find a common denominator. And a common denominator for 3 and 5 is a number that both 3 and 5 will divide into. And the easiest number is 3 times by 5. So 3 is into 3 times by 5, which is 15, goes 5 times. So if I've multiplied 3 by 5, I must multiply by this 1 by 5. So that's 5 minus, I've multiplied 5 by 3, so I multiply this 1 by 3, equals 1 over u. Now if I did that here, I've got to do it over here. So I want a common denominator. Here, the common denominator I took was 3 times by 5. So let's take f times by v. I've multiplied f by v, so I must multiply the 1 by v. Minus, I've multiplied the v by f, so I must multiply the 1 by f. And now, if I come back over here, let me just simplify this. This is 2 over 15 is 1 over u. And now I've got a complete fraction on both sides. I can turn it upside down and say that's what u is. Now, there was a lot of calculation went on here. I can't do that calculation here, but I have got a complete fraction here. So I can turn it upside down to give me u. So let's take as our final example the time dilation formula from relativity. And the formula is T equals T naught divided by 1 minus v squared over c squared to the power a half, or square root. So let's take some numbers. And in fact, what we're going to be after is we're going to be looking for this expression here, v over c. So let's just write that down there. That's what we're going to be looking for. Can we get v over c in terms of t and t naught? So let's have 6 equals 5 over 1 minus x squared to the half. Now, solving this, what would we do? Well, we've got a square root. Let's square both sides in order to get rid of that square root. So that would be 6 squared equals 5 squared all over 1 minus x squared. So let's do that here. Square both sides. T squared equals T naught squared all over 1 minus v squared over c squared. What now? Well, here the term I want in x is in the denominator. I need it upstairs, so let's multiply both sides of this equation by 1 minus x squared. So that would be 6 squared times 1 minus x squared is equal to 5 squared. So let's do that here. T squared times 1 minus v squared over c squared is equal to T naught squared. Now, I want the x squared bit. and it would be nice perhaps to multiply out the bracket, but there's a slightly quicker way. I can divide both sides by 6 squared. And that's nice because it keeps the square bits together, so to speak. So let me do that. 1 minus x squared is equal to 5 squared over 6 squared. So I'm going to do that here. Divide both sides by t squared. 1 minus v squared over c squared is equal to t naught squared over t squared. Now, running out of paper here, so what I'm going to do is turn over and write this one down at the top of the next page and this one as well. So we've got 1 minus v squared over c squared is equal to t naught squared over t squared. And here with 1 minus x squared was equal to 5 squared over 6 squared. Now it's the x squared that we're after. So I can add x squared to both sides. So this is 1 equals 5 squared over 6 squared plus x squared. So let me add v squared over c squared to each side. 1 is equal to t naught squared over t squared plus v squared over c squared. Now I want the x squared on its own, so take these away from both sides. 1 minus 5 squared over 6 squared is equal to x squared. So 1 minus t naught squared over t squared is equal to v squared over c squared, taking this away from both sides. Almost there now. It's x that I want, not x squared, so let's take the square root of both sides. So do the same here. It's v over c that I want, so let's take the square root of both sides. And that's it. We have found the ratio of the velocity to the speed of light in terms of the 2 times. So, that concludes this video on transformation of formulae. The thing to do is to treat it always as though it was an equation that you were trying to solve in terms of the variable that you want. X equals, G equals. And you just perform the steps as though you were solving an equation. If you keep that in mind, then most of your problems should be taken care of.